This video contains a paid partnership with BetterHelp. Hello and welcome to this episode of Night Sky News for September 2023 with me, astrophysicist Dr. Becky Smethurst. This is the show where we chat about what you should look out for in the night sky in the next couple of weeks, and then we chat about what's been happening in space news for the past few weeks. This month we're chatting about JWST adding more fire to the crisis in cosmology, and the latest evidence from the Curiosity rover on Mars showing that Mars once had a water cycle like Earth's, plus of course the Chandrayaan-3 mission to the moon. There's chapter markers down here if you want to skip ahead to any specific news story, plus any scientific research papers I mentioned are all going to be linked in the video description down below, free to read. So without any further ado, let's kick things off and start by looking up. So first up, on the 15th of September, the day after this video comes out, we're going to have a new moon, which means the sky will be much darker than normal, making this weekend the perfect time to see the densest parts of the Milky Way, our galaxy of billions of stars stretching out over the sky. See if you can spot it this weekend before it either drops below the horizon for those of us in the northern hemisphere, or it just gets too close to the horizon to see much for those in the southern hemisphere as we approach equinox on the 23rd of September. Remember, the longer that you give your eyes time to adjust from the bright lights of home, the more stars you will see and the more detail in all of the dust lanes as well. Plus, of course, a camera with a long exposure will always be able to pick up more detail and more stars if you want to try your hand at some astrophotography. Now, while you're out there looking for the Milky Way, on Saturday the 16th of September, just after sunset, look towards the west and see if you can spot the crescent moon, or as I like to call it, the Toenail moon, pairing up with Mars. They are very low on the horizon though, so blink and you'll miss this because they're going to set pretty quickly after sunset. Now, for those of you with telescopes this month, heads up that Neptune will be in opposition on the 19th of September, meaning it's in 180 degrees opposite direction from the sun in the sky, so it's perfectly lit from our perspective here on Earth. It will be the brightest it will get in the sky, plus it's going to be visible all night from wherever you are in the world. So it is a perfect time to try and spot Neptune with that bluish glow that it has, but again, you can only do this with a telescope. It's too faint to be seen with the naked eye, unfortunately. It's around about 50 times fainter than the Andromeda galaxy, which in the darkest of skies appears as just ever so slight fuzzy patch to the naked eye. But don't worry, all of you that don't have telescopes, because Jupiter and Saturn can be seen with the naked eye, and they're visible pretty much all night right now. Now, on Tuesday, the 26th of September, the very nearly full moon will be close to Saturn on the sky, making it much easier to spot Saturn with its yellowish glow if you don't know what you're looking for. Now, if you keep an eye on the moon the rest of that week, it's going to be a full moon on the 29th of September, another one that's close enough to Earth in its oval-shaped orbit to classify as a supermoon. And then by Sunday, the 1st of October, the moon will then be close to Jupiter on the sky, which after the moon is the brightest thing in the evening night sky right now, so you can't miss it. Since we're going to be very close to a full supermoon, the moon will be a lot brighter than normal, and so we'll wash out a lot of the stars and planets in that area. So Jupiter and Saturn, when they're close to the moon, they won't appear quite as bright. But once you've spotted them with the moon to help you know where to look, you can then go back a week or two later in that second week of October, hopefully on a clear night, to see them again in much darker skies. And then as we get further into October with later sunrises here in the northern hemisphere, see if you are up early enough to spot Venus and the crescent moon before the sun rises on Tuesday, the 10th of October. Once Venus does rise in the early morning sky, it is the brightest thing after the moon. Brighter than Jupiter, because even though Venus is a lot smaller than Jupiter, it is that much closer to us as well. Again, you're going to need a fairly clear horizon to spot this. And also the further north you are, the better chance you have of spotting this, because they'll rise higher in the sky before the sun rises behind them. All right, I think that's enough of looking up at the night sky. But before we chat about what's been happening in space news, I just want to say a big thank you to BetterHelp. This is a paid partnership with them. Taking care of your mental health is so important. Like, I love my job as a researcher, but being an academic is hard. it comes with so much pressure to succeed, and there's no job permanence either. And then doing all of that alongside producing a video every single week for YouTube, it's very easy for me to become completely burnt out. But therapy has given me the tools I need to manage my mental health and also just become aware when everything is just becoming too much. Honestly, I used to think therapy was just for people who had like clinical mental health problems like depression. But therapy is for anyone who might be struggling, no matter how small you think that struggle might be. Which is why I'm so excited to be partnering with BetterHelp, whose mission it is to make therapy accessible for everyone. Because finding a therapist and also finding time for therapy can be hard. BetterHelp is a platform that makes doing all of that easy because it's online, your therapy is done remotely so you can fit it around your lifestyle, and by answering a few questions, BetterHelp can match you to a credentialed therapist in as little as a few days. But if you don't really fit with that therapist, which is pretty common in therapy, you can easily switch to another at no additional cost. So if you think that therapy could help you, there's a link in the video description to betterhelp.com/Dr. Becky. Clicking that link does help support this channel, but it'll also get you 10% off your first month with BetterHelp so that you can find a therapist and see if it helps you. So thanks again to BetterHelp. And now let's chat about what's been happening in space news in the past month. All right, let's start with the south pole of the moon, because not one, but two missions tried to land there this month. First, Roscosmos's Luna 25, which unfortunately crash landed on the surface of the moon on the 19th of August and left behind a crater about 10 meters wide. And then the second one was ISRO's Chandrayaan-3, which successfully soft landed at the south pole of the moon on the 23rd of August. Now, this was not a given that landing would be successful, as we saw with Roscosmos's attempt. The South Pole is notoriously difficult to land on because it is so incredibly cratered. It's pockmarked, essentially. Compare that to like the Apollo missions in the 60s and 70s, which picked flat lava plains to make landing that much easier. But the South Pole has these huge ridges on the edges of craters that can be kilometers deep. And so these ridges cast long, strange shadows, especially with the sun at such an odd angle close to the horizon as well. That really doesn't help with navigation. And so that, along with just landing on a very uneven surface, these whole missions were fraught with difficulty, which is why it was such a huge achievement for ISRO, who were the first space agency to prove it was possible to land at the South Pole of the moon, at least on their second try anyway, after Chandrayaan-2 crash landed in September 2019. So you might be thinking, why do we even want to try and keep attempting to land at the South Pole? Well, these craters, which are kilometers deep, will have been permanently shaded from sunlight and all of the chemistry that triggers on the moon, which means there could be water at the bottom of these craters in the form of ice that's been there for billions of years. Now, that's exciting for two reasons. The first one is sort of a space exploration reason. NASA's plan is for a moon base that you then launch missions onward to Mars from. If there's a significant source of water on the moon, then you could use that for life support for your astronauts at your moon base, right? For drinking water, but also, producing oxygen as well. But the other thing that you can use it for, and just like Mark Watney accidentally does in The Martian, is to make rocket fuel, splitting out the hydrogen from water, H2O, right? So that you can use that hydrogen as rocket fuel for your missions onward from the moon to Mars. If you have the source of water there, that means that you don't have to, ship it from the Earth to the moon with constant resupplies, which gets very expensive, right? Anybody who's ever been hiking will know how incredibly heavy water really is, and the heavier a rocket launch, the more expensive it becomes. So if that source of water is there, it would solve a lot of problems for these moon bases and onward plans to Mars as well. But the second reason that finding water ice at the bottom of these craters is exciting, and in my opinion, the more exciting reason, is science. And the reason the far side of the moon and the South Pole is so craters is it because it acted as a bit of a shield to Earth in the early days of the solar system when there was lots of impacts with asteroids and comets, something called the Late Heavy Bombardment. And one of the leading hypotheses for where Earth got all its water from is from impacts with asteroids and comets during that Late Heavy Bombardment, because what we think happened was that asteroids and comets brought water from the far edges of the solar system where we think you're much more likely to actually find water, and brought it to the inner solar system where you then impacted with Earth and deposited that water there. The thing is, we don't have any record on Earth of any of those impacts due to, weathering and plate tectonics, which destroys all of the evidence. But the moon is like this perfect fossil of what happened all those billions of years ago. So if Chandrayaan-3 does find a significant amount of water ice at the bottom of these craters, as we suspect, there's then lots of questions going to be raised, right? How much is there? Because you need to know, obviously, if you want to use it for space exploration, but also how much is there will help us constrain our models of, how many of these impacts there were and when did they happen and how much water did they actually bring to the moon and to Earth with every single impact. But you can also then look at the atomic makeup of the water you find and say, okay, what's the fraction between, the water molecules that have hydrogen versus deuterium in them, like heavy hydrogen. So how much of it is heavy water, and compare that to sort of the deuterium fraction we see here on Earth. So we can sort of say, does the water on Earth and the water ice on the moon have the same sort of source as these impacts as we think? So lots of exciting questions to be answered with the data from Chandrayaan-3, which has already been taken in the 2 weeks since it first landed. On the 6th of September, it actually went into a hibernation mode because this area of the South Pole has gone into lunar night, pointing away from the sun, and Chandrayaan-3 is solar powered. The electronics on board were not built to withstand the minus 120 degrees Celsius temperatures that you get during lunar night. However, the battery is fully charged, and the hope is that it can be reawakened on the 22nd of September when sunlight hits those solar panels again, and maybe then it can start collecting more data. Now, researchers at ISRO get first look at the data, but eventually that data will be made public as well, presumably after the sort of first initial results have been published by the Chandrayaan-3 team. So I'm excited to see what that data looks like and also what they find as well. Now, from water ice on the moon to water on early Mars, with this research paper from Rapin and collaborators who studied images from the Curiosity rover on Mars. Now, I know Perseverance rover has been stealing all the headlines lately, but Curiosity is still operational, having driven over 30 kilometers from the Gale crater to Mount Sharp, over 3,940 sols. That's just over 11 years. So Curiosity has this incredible legacy. But one of the main mission goals for Curiosity was always to determine if Mars ever supported life. Now, for life here on Earth, as we know it, we know that it needs water to survive. So the question really has always been, has Mars ever supported liquid water, water that's flowing on its surface as well? Now, we know there are huge deposits of ice on Mars. It has large polar ice caps, but we also know there's a lot of subsurface ice on Mars as well, which gets exposed during impacts with asteroids so that we can spot it with satellites orbiting Mars, like the Mars Reconnaissance Orbiter. I thought that volcanic activity can also expose subsurface ice like this as well. But the thing is, because Mars's atmosphere is so thin and the pressure is so low, as soon as this ice is exposed, it just instantly vaporizes into a gas and then is lost into space. So we don't think that there's any liquid water on the surface of Mars today. But the geology of the rocks on Mars tells us a different story about what was going on in the past. For example, Gale crater, where Curiosity landed, appears to be a dried up lake bed. And then you've got Jezero crater, where Perseverance is, that's also thought to be a lake bed, but with evidence of it being fed by a river delta. What we don't know, though, is if these craters being flooded with water was a one-off occurrence, like after a big impact or a volcanic eruption billions of years ago, or if that water was there for a prolonged amount amount of time back when Mars's atmosphere was much thicker and it could support liquid water before it had been stripped away by all the high energy radiation from the sun, meaning that Mars could have been more habitable to life in the past. But Rappan and collaborators noticed some features in images taken by Curiosity in the Gale crater on its 3,154th mission Sol, aka in June 2021, that suggests repeat floodings of the crater. Now, these hexagonal patterns here are mud cracks, and you might have seen something familiar before if you've been to Death Valley National Park in California, where again, we think there was a lake that dried up about 10,000 years ago. But you'll notice that the Death Valley mud cracks are much more square in shape than hexagonal like the ones seen on Mars. And that's because when mud cracks first form, they do form with this sort of like T-like shape with like 90 degrees between the cracks. And then they dry out some more and they sort of like curl up a bit and shrink a little bit. That's what we see in Death Valley, a lake that was there once and it has dried up and there has been no water there since. That process only happened once. But if you re-flood the same area, then you'll get all sort of like the water and silt filling all of these cracks. But if it dries up again, then you've also got these weak spots where the cracks used to be, so it's likely to crack again in the exact same place. And then again, they'll sort of shrink as they dry up further, and you'll slowly but surely soften the edges, those 90-degree edges of that T-shape. And we've seen this happening in a lab to clay. And if you do it enough times, after about 10 cycles of wet and then dry again, those T-shapes have softened into Y shapes with 120 degrees between cracks. Meaning that if you have enough of them all together, they'll make hexagonal crack patterns, which is exactly what Rappan and collaborators spotted on Mars, which is a big deal. It means that these craters in the past on Mars were flooding and then drying out and flooding and then drying out. So you had liquid water flowing regularly on the surface of Mars, perhaps even seasonally, just in the same way that we have wet and dry seasons here on Earth, and these wet and dry cycles. And crucially, it's these wet and dry cycles that actually contribute to the conversion of elements and atoms into life-building molecules. So, taking nucleotides and turning them into RNA and DNA molecules, or proteins into amino acids. You need this dehydration and rehydration cycle to make that chemistry happen. Now, we know that those raw ingredients exist on Mars, and we now know that the conditions you needed to make the chemistry to turn those into the building blocks for life also existed in the past on Mars, which is very exciting, but it's not evidence for life existing on Mars in the past, because just because you had the raw ingredients there and the chemistry needed to turn those ingredients into the building blocks of life doesn't necessarily mean that life actually emerged. But it is one step closer to answering the life on Mars. But what's more is that chemical evolution from elements to nucleotides to DNA to maybe life could actually be fossilized in the rocks on Mars. We don't have that here on Earth thanks to all the tectonic plate activity that we have destroying the evidence. So if we could access this fossil record, either with Perseverance's rock samples if we get lucky, or like in a future mission to Mars that does rock sample collection, then we wouldn't just learn about the evolution of sort of like early life on Mars, but we'd learn something about how life on Earth emerged as well. All right, on to JWST now, and let's start with this stunning image of the famous supernova remnant, Supernova 1987A. So a supernova, or the death of a star, that occurred in the Large Magellanic Cloud, one of the little satellite galaxies in orbit around our galaxy, the Milky Way, which we detected the light from here on Earth back in February 1987, and it was so bright that it could be seen in the night sky with the naked eye. Now, we've seen detailed images of Supernova 1987A with the Hubble Space Telescope before, looking at it with optical light. But we've not seen it to the same level of detail in infrared light, because infrared infrared light is a longer wavelength, and as you go to longer wavelengths, your resolution of your telescope drops, and so you need to increase the size of your telescope to compensate for it. So with the 0.85 meter Spitzer Space Telescope, we didn't really see much in the 1987A supernova remnant beyond some blobs. But with the 6.5 meter JWST, we get to see supernova remnant 1987A in infrared light in incredible detail, with shorter infrared wavelengths colored blue here to pick out the hotter regions, and then longer infrared wavelengths colored red to pick out cooler regions. And the key thing about infrared light is that it can pierce through dust. It doesn't get blocked like optical light does. And supernova, they actually produce and then distribute dust out into the universe. So this image of supernova 1987A was actually captured as part of this proposal from Matsuura and collaborators to use JWST to study it, the nearest supernova detected in the last 400 years, to study the supernova process in much greater detail. We've just got the images for now. There's no research paper been released with this, and I think that's because the images were taken back in early September 2022. So the proprietary period on this data has now run out. That's the sort of year's time that the research team who applied for the data get to see it first before it's released to the public. But I imagine the research paper is not far behind, as this group of collaborators really are experts on supernova 1987A. And last but not least, let's talk about the impact that JWST is having on the so-called crisis in cosmology. Because this paper from recent collaborators appeared online at the beginning of August. And it's not yet peer-reviewed, so it's not been independently assessed by another expert in this field so that it can be like officially published in a journal. And because of that, I was gonna wait till it had been peer-reviewed to cover it in a video on this channel. But then the New York Times were like, nah, we're not gonna wait. It wrote a whole article on the crisis in cosmology and included the results from this paper, which resulted in a bunch of you sending me the article going, what is going on? And so here we are. So take everything I'm about to say with, a large pinch of salt, because in the peer review, the results, so the conclusions could change slightly if they find any inconsistencies with the method or with the data. But having said that, let's start with a very rapid recap of what actually is the crisis in cosmology. Well, essentially, we have two main ways of measuring the expansion rate of the universe, which can then tell us how old the universe is. One of those methods uses either supernova or Cepheid variables in, nearby-ish galaxies to us to calculate the expansion rate, and the other one fits a model of the entire universe to observations of the cosmic microwave background, the echo of the first light emitted in the universe, to get at the expansion rate. And those two methods are giving us completely different numbers. And the errors on those measurements are getting smaller and smaller all the time, so each different group thinks they're getting more accurate, all the while drifting away from the other group's measurement of the expansion rate of the universe. So the thought is either there's an issue with our observations of supernova or Cepheid variables in nearby galaxies, or two, there's an issue with the model fits the cosmic microwave background. If you want more detail on this, I've made many videos on this channel before about the crisis in cosmology that go into way more detail than that rapid recap did, if you want to check them out. Now, the hope is that JWST would be able to help us with option one, whether there is a problem with our observations of the supernova or the Cepheid variables in nearby galaxies. Because to calculate the expansion rate of the universe using supernova or Cepheid, some form of star in a nearby galaxy, you need two things. First, how fast the galaxy that star, that supernova or Cepheid variable is in, is moving away from you. And we can get that from a simple Doppler shift of the light to longer wavelengths, what we call a redshift that we measure in a spectrum. And secondly, how far away that galaxy is, which is what you use the supernova or the Cepheid variables to do. So here I'm going to focus on how we actually get distances using the Cepheid variable stars, because that's what this paper by recent collaborators has actually used. So Cepheid variables are stars that pulse. They change their brightness with a period between those pulses that's directly correlated with its maximum brightness. So if you measure how often a Cepheid variable star pulses, you know how bright it should be at its maximum. And if you compare that to how bright it appears to us at its maximum, you then know how far away the star is, and therefore the galaxy is that the star is in. Sounds simple. The problem, though, is actually isolating the light that is just from the Cepheid variable from other stars around it. Because as you go to more and more distant galaxies, our telescopes don't have the resolution to resolve those separate stars, and they all blend together into one blob. So the thought always was that these observations of Cepheid variables or supernova, whatever star in a galaxy far away that you're using to do this, were biased bright. Essentially that you were attributing too much light to the Cepheid variable, and therefore you think that star and therefore that galaxy that it's in is closer to us than it actually is, which would steepen the slope of this line on this graph, which gives you a larger value for the expansion rate of the universe, and therefore explain why these measurements give you a larger value than what they find with the cosmic microwave background. But with JWST, it's a very big telescope and it has the resolving power to actually separate out the light from the Cepheids from other stars, and so you should be able to get rid of this biased bright problem. Now, the same group of researchers actually published a first look at this with JWST data back in late 2022, which I actually covered in a video on this channel, which I'll link below if you're interested. And they did it for the Cepheid variables in just one galaxy, NGC 1365. But now, in this latest paper by recent collaborators, they've looked at Cepheid variables in two more galaxies, NGC 4258 and NGC 5584. And you can see in these images that for each individual Cepheid variable in this galaxy, so down each column here is one individual Cepheid variable, you get much better resolution from JWST, shown in the magenta there, than with HST, the Hubble Space Telescope, in black. And you can much more cleanly separate out the Cepheid variable from the surrounding stars. But what recent collaborators found was that, okay, yes, the JWST data increased the accuracy of that correlation of the Cepheid variables between the brightness and their period, which is shown in the red points there. You can see it's really reduced the scatter compared to the Hubble Space Telescope data, which is shown in the gray. But yeah, although the scatter has been reduced, that correlation between the brightness and the period has stayed the same. And so the distance that you get out from these measurements won't change. And therefore we haven't been underestimating the distances, and there's going to be no shift in the slope of the line that you use to measure the expansion rate of the universe. So it seems like there's a slowly growing pile of evidence from JWST that we can rule out option one as the issue that's causing the crisis in cosmology, or the Hubble tension as it's also known. And that suggests there could be something wrong with our best model of the universe, which if there is, would be really exciting, because then we definitely learn some new physics there. But also it could just be, that maybe there's some issues with the cosmic microwave background data. Maybe there's some systematics in there. Maybe there's some issue with, putting the data into the model. Who knows? Or maybe also it's just too early to say yet and to rule out option one because there's not that much JWST data from it. But there is more coming, not just for the Cepheid variables, but also for supernova and for TGRB stars, which also have sort of like a little quirk like Cepheids, so that we can use them to work out the distances to their galaxies. And again, we'll check if they have been biased bright. As I said, those observations are coming from another research group, this time independent of recent collaborators, which is actually led by Wendy Freeman. Don't worry, I'm keeping an eye out for the analysis of that data to be published, and you know that when they are, I'll cover it right here on my channel. And until then, I guess we just all wait with bated breath to see what JWST is going to reveal to us about the origin of the crisis in cosmology. All right, that's it for night sky news for this month. As always, if you snap any pictures of the night sky or you see any space news stories online that you want me to explain in a future video, then send them my way over on social media. As a reminder, the paperback version of my book, A Brief History of Black Holes, comes out in the UK on the 21st of September and in the US on the 24th of October. There's a link in the video description down below if you want to pre-order a copy of the paperback, but at that link you can also grab a copy now of the hardback or the ebook or the audiobook, which I narrated myself. So with that embarrassing bit of self-promotion aside, until next time everybody, happy stargazing. You are going to need quite a clear horizon to spot the Venus and the moon. It's weird, it's Venus and the moon rather than like Venus and moon. But, it's because the moon is the moon. We don't call other planets Venuses. And if you want to spot this, the Venus again, that much easier. One of the leading hypotheses hypotheses. One of the leading hypotheses. Well, it's a single hypothesis. One of the leading hypotheses. Why do I want to make it plural? One of the leading hypotheses. Okay, so there's many leading hypotheses, but I'm just talking about one of them, right? Space is hard, words are harder. It's thought that volcanic activity on Mars can expose this subsurface ice like this. Ooh, I tried to lean on my chair and missed. Oh, man, I'm getting too hot. Or if that water was there for a prolonged. Is there life on Mars? I just need to grab a book, Johnny. Just give me 1 second. It's like crawl over this bed to a giant box over here. Get a book out. There we go. And then I crawl back again. Oh God. Oh, what have I done? I'm like nudging everything. I'm okay. I got the book. Let's fix my hair since this is the outro that people will be watching. She says maybe people just click off it. Do you watch till the end? Let me know in the comments. So with that shameless bit of self-promotion aside, I dropped my book. I'm so sorry, book. The paperback copy of my book, A Brief History of Black Holes, is out in the UK on the... Oh, that was really nice. I'm sorry. So warm in this room. Why did I think it was a good idea to film the hottest part of the day? It's like 30 degrees outside and I'm just slowly melting.